Hello again. In this video, we're going to go through the things you'll need to know about Stata to complete the empirical assignment for Chapter 10. I'm going to stay out of this video, just do an audio voiceover so you can see the things on the screen as I'm using the statistical package to illustrate things. And so the things you need to learn how to do for this assignment are first how to generate new variables like the log of a variable or the square of a variable or pretty much any transformation you want to do. So we'll learn how to use the generate command. Then we'll run a basic regression, but it'll be a panel regression, so we'll use clustered standard errors. I'll show you how to do that. Then we'll learn how to add fixed effects to the model, how to add both fixed effects and time effects. And then finally, we'll look at how to do an F-test. And I'm going to show you how to do these assignments two different ways. One's just a point and click method, and the other will be to use what's called a do file, which you can then run, and it'll execute a series of commands that can do the assignment for you. The do file method is probably the best way to learn how to use this in the long run, because as you go through this first way I'm going to do it, if you make a mistake along the way, it's a lot harder to go back and fix the mistake. With the do file, you have all the commands right there in front of you, and it makes it really easy to edit things or change the model. If you want to change the model at all with the point and click method, you have to go back through and redo every single step. With the do file, you can just edit the commands and go in there and just rerun that. It's a lot faster. But anyway, so here's the point and click method. Now I'm going to use a different data set, but I'm basically going to run exactly the same kinds of regressions and other sorts of things you'll need for your for the assignment. And so the data that I'm going to use, it's another problem in the text. It's not in the text actually, it's on the class website. It's an extra problem. Anyway, this is about how seatbelt usage affects the fatality rate. So we're going to want to do things like, and the data is across all 50 states plus the District of Columbia, so there's 51 entities. And the data runs from 83 to 97, so there's 15 years. So 51 entities in 15 years. So we want to see how seatbelt usage, speed limit, blood alcohol limits, drinking ages, income, and things like that, age, the average age, say, in a state of drivers, affects the fatality rate. So the first thing I need to do is get my data into the program. And so I'll just click File here, go down to Import, and I want to bring in an Excel data set. You can bring in other types here, but I want to bring in Excel. And so it's going to ask me to look for it, so I'll click on Browse. And my data set's called seatbelts.xls, so I'll go ahead and open that. And notice there's it gives you the first few observations here. You can take a look at them. But notice the first row here is the variable names. So I want to click this box that says import first row as variable names. And now it's all set. And I just say OK. And if you want to, if you're not sure, you can go up here to the data browser, take a look and see what your data looks like. Looks like it all came in fine, so I won't spend much time there. You could have actually typed this command down here. This actually gives you the path. You can see the path to my file is this that you'll need to read in the data. And I'm going to use this command later when we do the do file. So as you do these commands, as you do these point and clicks, the individual commands come up here on the screen, and it's good to learn those. I'll come back to that. Okay, so the data's in. Now this is actually a panel data. So I want to declare it, let the system know that it's a panel data. So I'm going to click here on Statistics. And if you go down here, there's a line called Longitudinal Panel Data. That's what I want. We're using panel data. Data setup in utilities, need to use that. And I just want to declare this data set to be a panel data. Now, panel data have two dimensions. There's the entity ID, and in this particular one, it's FIPS, FIPS. In your assignment, it'll be a variable called state ID. So when you put a variable here, you want to add state ID. The time variable, I got to click this box to let it know there's one, is just year. And that's the same thing it'll be for you. And so I'm going to bring this in. It tells me, it looks like it brought the years in right, 83 to 97, strongly balanced. It gives me my panel data here. I could have just typed down here on the command line down here, XTset FIPS year. It would have done the same thing as the point and click that I'm doing. So now I have my data in here, and I'm going to need the log of income as one of my variables. So the first thing we're going to need to learn to do is how to generate a new variable. And that's very simple. I'll just come down here to the command line. Here. Let's try to see if I could raise this up a little bit. Should be a way. Oh well. Oh, there we go. So go down here to the command line and just say generate the log. Oops, I want the variable called log, LNINC. That's going to be what I'll use for the log of income. And that's going to equal the log. The variable name on the data set is called income. And so this will give me a new variable called LNINC. So see here, this is the command. Now I could have gone up here where it says data, data editor, create or change data, and create a new variable. And I could tell it that my new variable name, let me just create even a different variable so I can show you how to do it this way too. So let's make this one called the log of income. And you would just do the same thing here. You'd say equals the log of income. Oops, I don't need the equals sign here. And that should do it. And see, look here. It does exactly the same thing. And so the point and click or the commands, just typing them yourself, give you the same outcomes. All right, now I have my variable, and I want to run a regression. And I want to run fatality rate on a bunch of different variables. I'll explain as I bring them in. So the way you run a regression is you just click on statistics. One way, I could do it from the command line too. I want a linear model here, and I just want a linear regression. The dependent variable here is fatality rate. Yours will be given in the assignment, of course. And then I just want to add a bunch of variables. So the first one is seatbelt usage. The second one, these are dummy variables for whether the speed limit. So it could be 65, could be 70. There's a dummy variable for whether the blood alcohol limit is 0.08 or below. So we'll bring that one in. There's one for drinking age, if it's 21. For some of these years it wasn't. In some. This variable that I created, the log of income, I could use either one, it's the same thing. And I also want to add age. Now we're almost set to go, but because these are panel data, I need to use clustered standard errors. So this robust standard error is what we used in 320. But now since we have panel data, we want clustered robust. So you click on that, and then you tell it what your cluster variable is. This is FIPS in this data set. Again, in yours, it'll be state ID. And then we're all set to go. Got all our variables and so on. And so we'll just say OK. And then the output comes up here for us. And so strangely, an increase in seatbelt usage, this coefficient of 0.004, seems to increase the fatality rate. That seems odd. It's not significant at the 5% level. You can see that here. It is significant at the 10% level. But that seems like a rather odd result. So let's see what happens if we go ahead and add fixed effects, entity fixed effects to the model. Before I do that, though, I want to show you a trick. I don't want to have to put all of these variables in every single time. So I'm going to create what's called a global variable. So I'm going to say global space parenthesis, and now I'm just going to copy these so I don't have to type them. Everything but the dependent variable. Put that in there. And then just close the parentheses. Oops, I forgot to name it. Let's call this base vars. So global, base vars, SB usage, speed 65. So those are all the right-hand. So these are the base right-hand side variables. And there it is. So now we've created a new variable, a new global variable called base vars. And I'll show you how to use that in just a second. So now we're going to add fixed effects. So now we need a panel data method because we're adding fixed effects, which is a panel data technique. So we're going to go down here back to our longitudinal panel data, and we're going to take a linear models. And this very first one, linear regression, one with the FE, that means fixed effects. There's some other things here we haven't talked about, like random effects. We're going to use fixed. So there it is. So again, we want the dependent variable to be the fatality rate. And now I could type all these variables in one at a time like I did before, bring them in one at a time. But if I just say $ base vars, it will pull in this list down here. And that'll be much easier. Now I want fixed effects. There's other sorts of things that you would learn about if you went on and took really advanced courses. And we also want to make sure we're using the correct standard errors. So we want clustered robust again. And we need to tell it our clustering variable, which is FIPS. And looks like we're all set to go. Hit OK. And there it is. So this is our fixed effects model. And now look what happened. The coefficient on seatbelt usage is actually now negative. It's not really large, but it's negative, and it's actually significant with a minus 3.46 T. It's significant at the 5% level. And so adding fixed effects really overturned the results. It looks like it made a big difference here. Now, the next thing we want to do is add add the time effects. Now, you can't just click a button for this, so I'm going to have to show you a trick, a really quick way to create the dummy variables that we need for the state fixed effects. So the command you need is tabulate, and I'm going to call them year vars, YRVARS. Maybe year dummies would be a better name for it since they will be dummy variables, comma, generate, parenthesis, year, close parenthesis. So let's see what happens when we run that command. Oops. I did this wrong. I made a mistake. Let me show you something you can do when you make a mistake. See over here the list of commands? Just click on that. It brings it back up. This should have been years. I'm not giving it a new name. This variable right here, I blew that. These are the new variables here, YR. This is the variable identifying the years, which for us was named years. So now it'll work. Should have worked. What mistake did I make? What was the name of the... It's not years. What's the name of the variable? It's just year. So let's get this right. Okay. This is how it goes sometimes. No problem. Just get it right. And there we go. So now we've got a set of dummies. Let's actually check. I'm going to go up here to the data browser. And let's scroll to the right here. And you can see, here's the variables we created, log of income. We did it two different ways. They're identical. And here's the dummies. You can see the data are ordered by year for each entity. And so you can see these are looking good. These are just dummy variables that are 1 when the year is a particular value. And so we've created a set of dummies, and their names are over here YR1 through YR15. So what this command does is it basically goes through, looks for the year, and creates a 1 whenever the year has a particular value. So when year is 83, it creates a variable with a 1, and it calls them year 1 through year whatever, in this case year 15. Now I'm going to create another global variable just to make it simple. So I'm going to call this one year vars. This is a mistake I made a second ago. I was thinking ahead to this step. Up here where I did year vars, I was thinking about this global part. Anyway, I'm going to call them, I'm going to bring in, I don't need year 1 because I'm going to drop a dummy so we don't have perfect year multilinearity. So the variables I want to include are the year 2 through year 15. So give me a second here. Year 5, 6, 7, 8, 9, 10, 11, 12, 13. There's even fancier ways to do these lists since it's consecutive, but I'll save that for some other time. So I've got another global variable called year vars. It's going to pull in all of those things for me. So there we go. So now we're set. We've created the year dummies for the year fixed effects. We've created this global variable that will pull them in. So let's do statistics, longitudinal panel data, linear models, linear regression with fixed effects. We already have, it saves the things that were already there for us. That's nice. We got fixed effects. Now we just bring in year vars. That's right. That's the right name. We just bring in the year dummies, the year fixed effects, and then go over here and make sure that the standard errors are correct. Oops, they're not. So we need to, it actually reset those. So we need to make sure we've got that right. We do now. FIPS. So here's our base vars. This is that list of variables up here that we created. So this is this. I could have gone down here and just added these all individually instead of using. So I could have said fatality, SB usage, but those are all part of the base vars. So I don't need to do it that way. So this is a much faster way of bringing in all of those variables. So let's run it. There it is. What happened to seatbelt usage? Oh, it actually brought the T down a little bit, but it's still significant at the 5% level. Still negative, and it looks like it's a little bigger. I can't remember what it was. A little smaller than it was before. But this is probably the most reliable model because it has both the year and the entity fixed effects. Now, the very last thing you need to do is to do an F-test. And I'm going to do an F-test that these year variables, these year fixed effects, year 2 through year 15, belong in the model. So the command is just test, and then you just list the variables that you want to exclude. Year 2, year 3, year 4, and so on. But I've already created a variable that has all those in it, so why don't I just use $year vars, and that'll do the test for all of those. So that's just like typing year 2 through year 15 into this list. And that should do the F-test for me. It does. F is 9.82. It's significant at the 5, even the 1% level. So it looks like those year variables are making a big difference. And if you look at these T's, it's particularly through these years when those year dummies seem to be mattering quite a bit. So that's one way to do this. Now another way is to use what's called a do file. Now let me clear all this. So let me open the do file editor. I've actually already created one, and this exact do file is in the pages section of the class web page on Canvas. And so you can find this do file, and if you want to, you can edit it for the assignment. It's mostly a matter of changing the variable names and changing the path to the data. So let me open it up here and you can see what it looks like. So here's the editor. I need to open the file I created. So it's this example do file here. Open. And here it is. So the first thing you do in this do file, this top stuff will always be the same. You don't really need to worry about it too much, but you tell it, sometimes these lines will go longer than one line. So what you do is you tell it that the end of a command is a semicolon. So whenever I put a command in, I didn't have to do this down here when I was using the command line, but here that tells it that it ends a command. Like see down here where that global variable is created? It goes for more than one line, and then we tell it that the command ends with a semicolon. If we didn't do this, it wouldn't know those two lines are all one command. That just makes it so it doesn't page things out when it gives you when it gives you the output file. And this just tells it here where the line size wraps. This is not a big deal. And this just clears everything on the screen before it starts. So here's the first thing that you'll need to change. So this creates an output file that has all the results in it so that you'll have it permanently. So this is just the path that you need. So I'm going to save it in a file called ee_10_1.log. And if there's one by that name there already, it'll replace it. And I'm going to use this. Now remember that first time when I brought in the data, when I said file, import, Excel spreadsheet, and I brought in the Excel file that we needed, the seatbelts.xls, told it the first line, and I said okay. No, I don't want to continue and lose my unsaved data, so I'm going to cancel this. But when I did this, it came up and gave me the path to the data. So if you're not sure what your path is, you can get it this way. Actually, let me go ahead and do it. This is going to get rid of all the data transformations and the dummies and everything that we did, but that's okay. The program will recreate them anyway. So let me bring in this Excel spreadsheet. Almost said dead sheet. First row. Okay. Yeah, go ahead. See this? This is the path that you'll need to the data set. You can use this sheet command or not. And so that's, if you don't know the path, that's the way to get it. So let me go back to the do file. Okay. So this is that path that creates a log file, an output file. And this is the data set. Now notice that this is not Excel, it's DTA. I've included DTAs in the problems. These are the Stata data format, and it needs to be a DTA format. It's exactly the same as the Excel data, it's just in a different, more compact format. When you have really, really huge observations with hundreds of thousands of observations, space matters, and this is an efficient storage method. And so most packages have their own data formats and they can use them efficiently. This just brings up some descriptive statistics. I didn't do that before. Then this is that generate command. You can shorten it to GEN. This is the log of income command. This is creating those year dummies. This is creating the global base variables. And then This creates the panel data set. It's that xtset command. That's when we went in and told it it was panel data. And then these are the various regressions. This is an ordinary regression on fatality rate and the base variables, this set of variables, with clustered standard errors, clustered on FIPS. So the variance covariance, there's something called a variance covariance matrix. Anyway, the standard errors are clustered. This adds fixed effects, and this down here will add the time variables. Then this will test. And all of these things with stars, star means I'm starting a comment, semicolon means I'm ending my comment. So if you want to put comments in there, which is a really good thing to do if you ever start programming seriously, because a few months later you'll go back, it'll make no sense to you without comments. Trust me, I've done this. But anyway, now we're all set to go. So we have our data set. You'll need to, your years are different. You'll have a different number of years in your data set. Your variable names are different. So in your data, this should be FIPS. That's a mistake in my comment. In your data, it's state ID, and mine it's FIPS. Let me resave that, fix that. Then the time ID for you is year in your data. But these variable names will all be different. But everything else is pretty much the same. So you'll be able to do it this way too if you want to. So now we just hit do, and hopefully I got this all right. And notice that what comes out is everything I did by pointing and clicking. And so the one thing we didn't do is a description. This just gives you some things. This is just the DESC command. I could do that down here with just DESC in the command line, and it would give that output. Just describes, this is summarizing, gives you means and standard errors, mins and maxes, things like that. This is where we generated the log and so on. And then you get your output just like we did before. Here's that last 0.0037 negative with the 2.5 second t. And then here's the test, the t-test that we did. And now the advantage of this is now I can go back and say, oh no, I really didn't want some variable in the model. So I could go in here and I could exclude from the base vars something, or I could add something to it and just rerun it right again. Like if I wanted to try it without age. I don't know why I would, but if I did, you just get rid of it, hit the do file again. And there it is. And the model will run again without age, and so on. And so it's really easy to do various things with these do files. And if you make a mistake, you can just go back in here and fix it, and you're all set. So that should be everything you need to know for this assignment, and I hope it goes well.